Alrighty, time to start a new streak since the last one was definitely broken. Still pondering it, but yeah, didn't get anything after sleeping on it. Oh well. Okay, anyways, concatenation of consecutive binary numbers, medium. You're given an integer n, return the decimal value of the binary string formed by concatenating the representations of 1 to n in order modulo 10 to the 9th plus 7. Decimal value of the binary string formed by concatenating the binary representations of what n is 1, output is 1. N is 3. In binary, 1, 2, 3 represents 1, 10, and 11. After concatenating them, oh, I see. 1 to n, 1 to that value. Return it modulo 10 to the 9th plus 7. Okay. Let me think. So if I take this whole number, there was a theory that relates how you find the modulo of huge numbers. What was that theory? How do you relate the modulo of huge numbers? So I think it's like something like a plus b mod k equals a mod k plus b mod k. That's just number theory. It's kind of a, it's almost like a distributive property of the operation. It's like a plus b times k equals a times k plus b times k. So here, if I have something that is powers of 10 basically, right? No, it's powers of 10 or powers of 2? Decimal value. So it's powers of 10 is the place values. So if I have something like 10a plus b mod k is equal to 10a mod k plus b mod k. So I can do the modulo operation on each kind of bit separately, I think. So it's like 100a plus 10b plus c mod k. So 100. Okay, I think maybe I need to focus on like 10a mod k. 10a mod k. 10a mod k. I think this is 10 mod. Is it going to break down? Does it break down to 10 mod k times a mod k? I don't think so. I don't think that works. 10 mod k plus a mod k. I need to bone up on my number theory in terms of properties, operations of products. Properties of product under modulo. The product property under module n states that the remainder of a product is equal to the product of the remainders expressed as a times b mod n is equal to a mod n times b mod n mod n. Okay, yeah, so it is 10. Okay, so this does equal 10 mod k times a mod k. A mod k under mod k. Okay, so that means that if I were to, because these are the 10 to 10 mod k or the 100 mod k and 1000 mod k, those are going to be the place value components to kind of binary to the bits in the binary string, and those are going to be also strictly unknown values because they're always going to be computed the same since the k is known, and you always have the 100,000 whatever place values. So in essence, if I can pre-compute that, then I can just compute the other stuff without having to deal with large numbers, really. Because a is just going to be 1 or 0. Yeah, okay. So I think I need to first determine the length of the string. Well, n is given integer n. What is n? N is the, okay, it's the, okay, so we'll say, what's another word? Guess I could create the actual string first. That makes sense to create the string. N is going to be pretty big, 10 to the 5th, okay. If I create 10 to the 5th, it would be 1. Maybe I don't want to do that. Actually, I don't even want to compute 10 to the 5th mod k either. Okay, I see. Maybe it's supposed to be 10, so like 10 to 100. 10 mod k versus 100 mod k. That's a factor of 10. So I can keep the previous kind of place value mod k and then multiply that by 10. Interesting. Maybe the hard part is actually the string. Having a 1 to n string. I mean, I guess you just iterate over n, right? Let me think. Because if you iterate from 1 to n, maybe you iterate backwards. You iterate from n to 1, since then you can actually iterate from the right side of the string to the left side of the string. Yeah, maybe iterate. Okay, yeah. So for every let's say value in range n down to 1. So first you get the binary. Let's say the binary thing is going to be maybe you don't want to do this actually. Getting a bunch of binaries is not great. Also, the value from one to the next one is very similar. One to the next one is very, very similar. Is it? Actually, maybe not. Maybe not. The binary is very similar, but not the overall value within the computation. Okay. All right, let's just go ahead and do this. The string of this is going to be bin of n doing 2 index 2 onwards, because then you're dropping off the first characters, since bin is going to give you 0b and then the binary version of it. So like 3 becomes 0b, a string that's 0b11. So 2 onwards from there. Actually, I don't even need the string, right? I shouldn't need the string because I should be able to just deal with the integer and parse the integer. Yeah, I should be able to parse the integers, really. Okay, I think I need something that is like PV for place value. So the place value starts with 1. And then the place value at the end of each loop should be PV is equal to PV times 10 mod the 10 to the 9th. So I think this actually occurs. I think I need to do something like for a while value is greater than 0. I need to work with the bits. It should be inside that loop. So I need to, so let's say it's 3. So n is 3, so I'm going iterating from 3 to 1. Value is initially 3. I need to take the rightmost bit of the value first. So the rightmost bit should just be and bitwise and with 1. Is that right? Bitwise and with 1. Bit equals value. Bitwise and with 1 will get me the rightmost bit. That rightmost bit, if bit equals 1, then it needs to multiply by the PV. So answer equals plus equals PV times bit. PV place value increases, and the value needs to shift. Value right shifts by 1 to remove that last bit. Least significant. this is by shifting bits right 1. So then this process the 1, then it makes it 1. And then the value becomes 2. Process the 0, process the 1. I guess since I only care about... Okay, this is probably too... I just need to say if the value... So if the rightmost bit is a 1, then just it increases by the PV. Because I know that 1 is the value that you multiply by PV. So the rightmost bit, which is the least significant, is 1 increase. Okay. I think that might be it. Wow, this should be mod. Let's go ahead and just do this there. That should work because it could technically get too big here. Yeah, it could be pretty big there. This might be still a little slow. Oh, shucks. Oh boy. 3 is wrong, huh? 27, ooh. So, corresponds. Am I thinking about this wrong? Oh, okay, so this is, so it still wants it to be represented as a, okay, I misinterpreted what decimal value, it still needs to be base 2, it's still binary, rather than powers of 10. Okay. Looks like it's slow. Unfortunate. Looks like it's very slow. Okay. Alright. Fair enough. Let me see if I can't speed this up. Okay, so dealing with powers of 2. PV equals PV times 2 mod. Do. I wonder, for every value in the range, I'm doing a bitwise processing of that value. So if it's 12, I'm doing 12, 11, 10, 9. So I mean, this thing suggests that I'm either off by an order of magnitude, which could just be related to the bitwise processing. I think my thing currently is like roughly O of n squared, whereas this should be O of n, maybe. Okay, so if it's 12, so let's go 8, 4, that's 12, and then 11 would be 1, 0, 1, 1. 8 plus 2 plus 1. And then 10 would be 8, 1, 0, 1, 0. Place value doubles each time. Place value doubles each time. To the 9th plus 7. Could do a bitwise shift by 1 on the place value. I wonder if there's a, it's almost like doing a dot product. Almost like doing a dot product. One, 1, 0, 1, 0, 0, 1, 0, 0, 0. Doing a multiplication. Am I doing a multiplication? Actually, is this necessary? 1, so 0, 0, 1, 1. Let's say that get to a point where the value itself is too big, bigger than 10 to the 9th plus 7. Then what could I do? Could concatenate. Could concatenate something. One, 0, 1, 1. Wonder if I can just pre-compute some of this stuff. Pre-compute values for 10 to the, I don't know, it would be pre-compute it for this was an even distribution of values of n. I can pre-compute 10 values. No. Interesting, interesting. "56 milliseconds. Seems like a pre-compute. Can I... Okay, say that I had... Let's say that I had n to the 5th and n to the 7th. So n to the 5th is 1, 2, 3, 4, 5. N equals 5 is that. N equals 7 would be that plus 6, 7. So there's some binary, some decimal value for this. Let's say that equals x. And then here this would be like, how many extra? There's 6 here, so it'd be 10 to the 6 times x plus y. No, sorry, this is space, still binary, so it's 2 to the 6. Or x shifted over 6 plus y. Yeah, this is, what I'm doing is I'm literally, what exactly am I doing here? I'm bitwise processing. I'm adding bits to that should be parsing left to right. Parsing left to right. So I have a number. So if I'm just parsing 5, if I go 1, 1, 0, does that work? So 1, the value there is going to be, let's say, initially 1, and then I double that value. Maybe I'm supposed to just do for every value in range n. Let's say the answer is currently 0. And then while the value is greater than 0, how would I get the leftmost bit there? Ooh. How would I get the leftmost bit of this binary? Because otherwise I'm going to have to multiply by a higher place value. If I can just parse it left to right, leftmost bit, 1, 1, 0. I guess how do you find this? Actually, the leftmost bit is always going to be 1. What am I doing? The question would be how I remove that leftmost bit. Is it be like, I want to go through bit by bit, left bit to right bit of the binary number. If I go left bit to right bit of a binary number, then it'd be like 1, 0, 1, 0. Hmm. One zero 1 0. Yeah, it's still not working. 1 1 0 1 1 1. Could keep an array. Could keep an array where the array is the actual bits. Maybe. Then I have to do the bit operations in it. Then I have to do the bit operations on the array. 1 1 1. Wise and the bit mask. I think I can do a bit mask. find set bits of binary number. Jack up a specific bit and a given position is set. You can use the bit mask and bitwise AND operator. Create the mask. Apply the mask. Perform the bitwise AND operation between the number and the mask. So if I just use a bit mask, knowing what the most significant bit is, create the mask. A mask is a mask with a 1 in the nth position and 0 elsewhere. Sure. Guess I'll just create 32 bits of mask. Not right. N is 10 to the 5th. So what is 10 to the 5th log base 2? So I need a mask that's 17. For, let's say, I, or something in range 17. I guess I'll do something like maybe 1 here. Mass appends 1, or mass, the last mask, and then bitwise shift by 1, so times 2. It should just be like 10, 1 to, what's going on, PB equals 1. What's wrong with that? Oh, this while loop. Okay, so there's the mass. Okay. I think I'll do something like as the mask index starts at 1 maybe for every value, and I think of this for every value in range 1 to n. So that'd be inclusive of n, so it should be 1 to n plus 1, not inclusive of n plus 1. At some point this should be mask index if the value is equal to the value at the mask index, then mask index plus 1, something like that. The mask index needs to correspond to be basically the most significant bits, mask for the value, and then I need to iterate over for every mask in range of its mask index, and then down to 1 or down to 0. So at value 2, value 1, this should be just 1, and value 2, it should be starting at 2, 1. Okay. Yeah, so I guess here this would be the bit is equal to the value bitwise and with the mask. I guess maybe no, this mask is actually the mask bitwise and with mask at mask. This is more of a actual iterator through the mask. And then if the bit, I guess I can just do if this is true, which means it's 1, then answer, well, technically it's always gonna, it should always increase the answer. Answer should always be shifted left by 1. And then if this is true, then answer should increment by 1. And then at some point I should do something like answer yeah, so this is not going to do 10 to the, it's not going to do the modulo correctly. It's going to do the modulo correctly. So if it was something like this, what happened with the modulo? 1, 1, 0, 1, 1. Mod k. Maybe it does do the modulo correctly. If I just do answer equals answer mod k here, where k is the constant. Alright, let's just hope. Oh, shucks. So I've got the first one. Oh boy. So it didn't even get that one right. So it didn't get the 27. Answer shift left by 1. That might not work, since that's going to increase the answer possibly over k. Okay. Answer equals answer times 2 mod k. Oh, how's that any different? Actually, this one shouldn't actually go over k at all here. So let's go ahead and just print out the answer each time here. So it starts at 0. Should probably be starting out at 1. Answer, shift left. If the value, this doesn't work. The very first go, I think this should be 1. 2 is not the right number. Mass index should start at 0. Yeah, okay. So that means this should be the value equals mass index. Value equals mass index. Okay, I think maybe that still doesn't work. Okay, 1, 1. Answer is 1. It's fine. And then the second iteration, the value is 2. Yeah, so 2 starting with the second. Yeah, 2 starting with the second bit, which has a mass value of 2. So that means 3. So yeah, that's those 2 is 3. And then 0 is going to be 6. That should be 20. So 3, 6, and that should be 13. Not sure why it's 12. Should be 13. Two, 1. Two, 1. 3, 4. Yeah, it should be 13 right there. Value's 3. Value 3, index is 4. Oh, shucks, I see. No. Yeah, I think I see. I'm iterating to the wrong index here. If value equals the next baseline. So value equals mass at is that how it works? Bit 1 matches 2 matches. 1 is the lowest of 1, 2 is the lowest of 2, 4 is the lowest of 4. So value plus 1 is equal to mass at index plus 1. Yeah, okay. Okay. Alright, time to see that it's the same speed or worse than before. Oh Lord. Oh Lord. Well, it's not worse. So it's worse memory-wise. It's not worse runtime-wise. 6200. But I even call that, man. If only this was an actual like distribution where on the right is the good end and on the left is the bad end. Oh boy. Hmm. Do I want to bother? Sometimes you are the hammer and sometimes you are the nut. This one, I definitely feel like the nut. So, I mean, the other thing is just pre-processing a few major ones, maybe like every 10 to the 5th. So pre-processing those and then just doing the bit mass from those values. I wonder if there's some other number theory thing I should be leveraging. There's definitely some other number theory thing I can leverage. I mean, it's not terrible code, to be honest. Well, in my mind. One. Shift, 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 shift. And to the answer bit by shift. My value. Hmm. 1, 2, 3. If I were to pre-compute this, it probably shouldn't be based on the actual values of n, it should be based on the value of the string, on the length of the string, such that it's evenly spaced. Okay. Alright, I'm gonna, so what's the biggest value here? Description, biggest value is 10 to the 5th. So 10 to the 1st, 2nd, 3rd, 4th, 5th. All right, I'm going to say, I'm going to pre-compute 10 values. So, pre-compute. I'll say if the value mod, okay, let's say divisor is going to be n divided by 10 if the value is evenly divisible by this divisor. Answer appends, or pre-compute appends this answer. Let's go ahead and do print the pre-compute. Excellent. Value mod. Let's say if the divisor and that. So this is the pre-compute. Let's append, actually let's do pre-compute is this value and the pre-computed answer. Interesting. Recompute. Oh, shucks. I think this still might be too slow because overall my algorithm is too slow. But should speed it up still, I guess. 1, 2. Why is the value increasing by? Why is the value just increasing by 1? Not like the value is the length of the thing. What is the length of the thing? For every value in range 1 to n plus 1. No, it shouldn't be. Value should be 1 to... what? I'm doing test case 2. Oops. Wonder if I should just be doing okay. So I need to just initialize to some initial answer and iterate. Maybe I need to actually store the mask index as well, the initial mask index. Gosh dang it. Oh my gosh. Okay, so going back to this thing, I need to append the value, the mask index. Is it the mask index? It's the mask index and the answer. And so I want to initialize based on those. So answer equals 0, mask index equals 0 initially. This is still always used. I can delete that. So I think I'd do something like start is equal to 0. No, start equals 1. Index equals 0, or pre-index equals 0, while start is greater than or equal to the pre-compute at the pre-index at element 0 in that tuple, then start increments, or start is equal, no, I'll just say this is, no, sorry, this while not the start, while n is greater than that, then pre-index increments. I could also use bisect left or something here. It's fine. N is greater than or equal to that. Increase the index. Guess this is actually the index I want to use. So I want to initialize the answer and the mask index, those things. So maybe this should be initially 1, 0, 0. So answer is equal to pre-compute at pre-index at 2, mask index equals, okay, actually, I think this is the starting value, the starting answer, no, starting mask index, and the starting answer is equal to pre-compute at pre-index. So while for every value from start, I think this is off by 1. Value should be start plus 1 maybe. Index out of range. N is greater than pre-compute at pre-index at 0. Greater than or equal to. Right. So I think this should just be greater than. Okay, well, one of the cases. The case that, yeah. So close, maybe? Case 3, 12. Case 1. So 1. I think this is just starting at the wrong thing. So if it's 1, the answer should be 1, or the filter should be 1. Filter should be, if it's bigger than 1, filter should be 1, the answer should be 1. Fuck. Okay. Mask index starts at 0. So it's inclusive of this thing. It's inclusive of this value. Should this still be 0? Mask index 0, mask index 1, mask index 2? If value plus 1, so currently value is going to be 2. Value starts at 2. Starting at start plus 1. Starting at start plus 1. Well, that should be 0, but I can check. Yeah, it's not 0. We computed the value is 1. Initially when I do the loop, when the value is 1, answer is going to be 1. Value plus 1 is going to be 2 is equal to mask index of 0 plus 1, which is 1. So that should increment to 1. So the mask index should be 1. Not sure why it doesn't. It's already around 2, 6. So it's like getting extra 0. Getting like 1, 1, 0. Doubling doubling the... Okay, so if this was 0, what would it be? Whoa, that's really big. That's really big. Why is that? While n is greater than pre-compute at pre-index at 0. Is 1,000. I see. Yeah, I think okay, yeah. Yeah, yeah. So it's greater than that. Okay. So while n is... So if it's 1, it should stay at 1. Infinity, infinity, infinity. Or let's say infinity here, -1 here, -1. So while n is greater than or equal to pre-compute a pre-index +1. Okay. Div not found. Do. Shucks. 2 instead of 6. Okay. Okay, I think this was hopefully because of this. Oops. Thinking it should be 1, 1, 1 there. Okay. Move the printouts and let's see if this runs any better. Okay. Okay. I mean, it's certainly not great, but it is a 5-fold increase in 5-fold. Yeah, I think that's a 5-fold increase in speed. I'm going to call that a small win. I am no longer at the extreme right end. I'm just at the right end. I'm just a factor of 2 rather than a factor of 20 or 10. Alright, whatever. I'm done with this one. I am done. Okay, so summary for this one is going to be, who knows? This definitely wasn't the optimal solution. Wasn't the optimal solution, but basically tried to iterate through the string from left to right. In order to do so, use bitmass to determine the next bit in the chain. Also used a precompute array for values that are every 10th of the maximum value of n in order to make this inefficient algorithm slightly less inefficient. So in general, ignoring the precompute stuff, you have a bit mask. The masks are going to be used to determine if a certain bit within the binary representation of an integer is 1 or 0. Since I want to go through from left to right, most significant bit to least significant bit, I basically have a tracker. My mask index is the tracker as to what is the most significant bit of a value of a particular integer. And then I iterate over the mask backwards from that mask index being the most significant bits index. Finding the value of that bit, incorporating that into my answer, where the answer basically doubles n plus 1 if that bit is 1, or just doubles otherwise. Because when you deal with more and more bits added to the right side of the binary, that doubles the value. Then at certain values, you need to iterate to the next max index, which is to say that the next value is going to have more bits in that you need to look at. So like 1 has 1 bit, 2 has 2 bits, 3 has 2 bits, 4 has 3 bits, and so on. So yeah. And then just return the answer in modulo. Time complexity, this is going to be O of, I want to say this is O of n squared. Which is slightly or greatly improved by the precompute. Yeah, I'm pretty sure the other solutions, better solutions, pretty sure that there are better solutions that are O of n, or possibly even O of 1. I'm not quite sure about that one. Base complexity, but I am currently unaware of the number theory involved for that, number theory or code involved for that. Base complexity, this can be O of 1, since I just have a fixed sized array. Work precompute is used, but other than that, no real